3 Atlas has come into the sights of Mars probes, and it seems to be becoming increasingly mysterious. At the beginning of October, the chunk approached the red planet at a distance of around 30 million kilometers and became the first interstellar object to be photographed from another celestial body. The ESA probe's Trace Gas Orbiter and Mars Express, and the NASA rover Perseverance, took a close look at our mysterious visitor. But strangely enough, they did not see a tail, even though the object has actually been active for a long time. At the same time, scientists have also discovered something that is completely atypical. The Swift research satellite has recorded that 3 Atlas is losing large amounts of water, even though it's still far from the Sun. But what is the reason for this unusual behavior? And why does the object behave so differently from all the comets we know from our solar system? Be sure to stay tuned until the end and find out with us. A few weeks ago, space research celebrated a historic moment. After the interstellar comet 3I Atlas approached Mars to within 30 million kilometers, it became the first interstellar object in history to be captured on camera from another celestial body. This naturally raises the question of why the chunk was photographed by our Martian outposts in the first place. And the answer is easy to find. Seen from Earth, 3I Atlas was almost directly behind the Sun, making it virtually invisible to ground-based telescopes. Fortunately, however, the view from the Mars probes was not clouded by the glare of sunlight. So, the Trace Gas Orbiter seized the unique opportunity and captured our visitor with its camera. Now, it's in the nature of things that the probe images do not achieve the razor-sharp quality of a James Webb telescope. Nevertheless, the Trace Gas Orbiter managed to take an amazing cosmic snapshot, showing 3 Atlas as a faint diffused point of light against the deep black background of space. But what, and this is the crucial question, are we actually seeing in the photo? Well, in fact, the blurry luminous structure is not the comet's nucleus itself, but its coma. So what we are looking at here is the glowing comet shell that forms when frozen gases and dust particles escape from the nucleus into space and are excited by sunlight to glow. The coma of 3 Atlas extends for thousands of kilometers and shows that the chunk is definitely active. And yet we search in vain for a comet-typical tail in the images. However, this is simply because the object is still in an early phase of its activity, which means that the ejected particles have not yet bundled together to form a tail. We will probably only be able to marvel at a tail visible from afar when the interstellar visitor approaches its perihelion, or in other words, its closest point to the Sun. Despite the absence of tails, the images are a resounding success for scientists, and not only because of the unprecedented location of the photographer. According to experts, 3 Atlas was 10,000 to 100,000 times fainter than anything the Trace Gas Orbiter's CASIS camera normally photographs. And as mentioned, this was only one of several Mars outposts that targeted the object. So what about the other images? What Mars Express and Perseverance have seen? Having arrived at Mars in December 2003, ESA's Mars Express probe has been exploring our reddish-shimmering neighboring planet for almost 22 years now. Recently, however, it too was quickly repurposed as a cosmic paparazzi and turned its gaze to the passing comet 3 Atlas. However, this view differs significantly from that of the Trace Gas Orbiter. While its CASIS camera has an exposure time of 5 seconds, Mars Express takes its images with an exposure time of only about half a second. As a result, 3I Atlas is not visible in the images, or rather not yet. In order to capture the faint point of light, the individual images are combined with each other afterwards. However, it's not yet clear whether the expert search for the comet has been successful, as the evaluation is still ongoing. In addition, Trace Gas Orbiter and Mars Express also attempted to analyze the light spectrum of the chunk in order to gain further insights into its chemical composition. However, in this case too, the results are still pending, and it remains to be seen whether the corresponding signal was strong enough. Of course, there are also the insights that Perseverance provided us with from 3 Atlas. Unlike the 2 ESA probes, the rover is not orbiting the red planet. Instead, it has been examining its dusty surface at close range for a good 4 years. And ultimately, Perseverance also succeeded in photographing the interstellar object. On October 4th, one of its navigation cameras captured a faintly glowing streak streaking across the darkness of the Martian night sky. However, Perseverance's navcam is not intended for astronomical observations in the traditional sense but is mainly used for navigating the rover. But on that night, it showed traces of the comet rushing across the Jezero crater at a distance of about 38 million kilometers. At first glance, you might almost think that Perseverance captured a long symmetrical comet tail, but that's an illusion. We have to take into account that the camera perceives distant objects differently. A single pixel covers around 12,000 kilometers. At the same time, the comet's movement during the exposure creates a long blurred streak of light. However, the actual size of 3 Atlas is estimated to be a maximum of 5.6 kilometers at its core, surrounded by the coma. This means that the photo motif is significantly larger than the comet itself. However, it should be noted that the situation is currently being complicated by political disputes. As is well known, the U.S. government has been in shutdown since October 1st, and NASA, as a U.S. federal agency, is also affected by this. In detail, this means that many NASA employees are currently on furlough and that there are significant delays in data processing and image release. 3E Atlas is losing water even though it's far away from the Sun. While the Mars probes were taking their historic images of 3 Atlas, the rest of the research community was not standing still. Quite the contrary, because at the same time researchers recorded another huge surprise. And since then we have known that the interstellar object is losing large amounts of water, even though it's still far away from the Sun. More specifically, this unexpected discovery is credited to SWIFT, a NASA research satellite that primarily detects and studies gamma-ray bursts. Now, however, SWIFT has succeeded in detecting water in the form of hydroxyl gas emanating from the comet for the first time. Briefly explained, hydroxyl is produced when sunlight splits water and is therefore an indirect but very reliable fingerprint of water. What particularly amazes researchers, however, is the fact that 3I Atlas is showing this activity even though it's almost 3 times further away from the Sun than Earth. Usually, water on comets only evaporates when they are much closer to our source of heat and life. Despite this, a clear signal of hydroxyl has already been measured, a signal comparable to a fire hose turned up to full power, spewing out 40 liters of water per second. To explain the observed amount of water solely through sublimation from the nucleus, at least 8% of the comet's surface would have to be active. And once again, for clarification, sublimation refers to the transition of frozen substances directly into a gaseous state without first becoming liquid. The problem, however, is that the activity value mentioned appears unusually high because most comets in our solar system have an activity level of less than 5%. And so it is that experts believe an indirect process provides the more likely explanation. More specifically, researchers suspect that the comet releases icy dust particles from its core, which evaporate in the surrounding environment and feed the coma. This type of scattered water source has rarely been observed before and indicates complex layered ice structures that form during the comet's formation. And when we compare 3 Atlas with its 2 interstellar predecessors, its uniqueness becomes even more apparent. While the first interstellar object, Oumuamua, showed virtually no traces of water, 2I Borisov was rich in carbon monoxide but only moderately active. 3I Atlas, on the other hand, shows strong water sublimation at a great distance from the Sun, reminding us once again that every cosmic visitor carries the unique chemical fingerprint of its home world. The research team led by lead author Zishir Xing from Auburn University therefore sees the discovery as important evidence because it shows that the chemical building blocks of life as we know it are not only found in our solar system. Furthermore, water is always a chemical key that enables us to understand the evolution of comets and planetary systems. In our home world, researchers use water to determine the activity of a comet, measure other volatile substances, and draw conclusions about the structure of the nucleus. The fact that an interstellar object now provides the same signal allows, for the first time, a direct comparison between the solar system and alien planetary worlds, and thus also an insight into the diversity of planetary chemistry in the Milky Way. And even if there are still many questions to be answered in the future, it is clear that 3 Atlas is so much more than just another visitor from interstellar space. It behaves completely differently from known comets. And as it continues to race through space, astronomers are already eager to see how its activity will change as it approaches its closest point to the Sun, and what secrets it will then reveal. And when you click to subscribe, you'll never miss a new video from us again. See you soon.